We physicists have waited 100 years since 1916 for this photograph. It is a region black holes might just be one of the most fascinating and mysterious phenomena in the universe. They are massive beasts in terms of power, but at the same time virtually invisible to us. A black hole could weigh perhaps 2 to 4 million times the mass of the Sun. Because of the research that has been put into them over the last couple of decades, we've gone from knowing absolutely nothing about them to getting to learn more and more up close and personal. While things have just gotten crazier, Michio Kaku just announced that we've finally gotten a look at what's inside a black hole. This new information brings light to the details the world of science might have missed all along. Join us as we dig deeper into black holes and unveil what's inside space's big bad. What are black holes? Before we get into the details of what Michio Kaku found, we have to talk about the first. Even though most of us have some idea of what black holes are, there are still some gaps in the right information. You see, in 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. At that time, the concept of black holes was purely theoretical. It took another 50 years for the scientific community to find evidence that black holes actually exist. This happened in the 1960s when they were studying the Cygnus constellation and noticed an oddly bright blue star emitting X-rays. This star wasn't a stagnant object but was going around a giant black something. Upon further investigation, it was found that the X-rays weren't just moving around on their own but were being sucked into the black thing they were orbiting, hence the name black hole. This discovery was significant because it provided proof that black holes actually exist and weren't just a figment of Albert Einstein's wild imagination. While that was great, it also meant that there was this unreal entity in space that we urgently needed to know more about, so researchers all around the world got to work. This black hole was named Cygnus X-1 and is located in the constellation Cygnus, about 6,000 light-years from Earth. It was no small discovery. It's about 14 times brighter than the Sun and incredibly dense, which causes it to have a strong gravitational pull. The gravitational pull is so strong that not even light can escape it, which is why it is called a black hole. The concept of a black hole is both fascinating and terrifying. It is a region of space where gravity is so strong that nothing, not even light, can escape. Anything that gets too close to a black hole will be pulled into it, never to be seen again. But that aspect of danger makes it even more necessary to learn everything there is to know about them. Was this it, or were we just beginning? The answer ended up being the latter. After the discovery of Cygnus X-1, scientists started to search for other black holes. They found that there may be close to over 100 million black holes in the Milky Way alone, but because they are so incredibly hard to detect, we still don't have an exact number. Nevertheless, from the looks of it, there are several million black holes in the Milky Way in our very galaxy, which makes them even more important to study. So let's break it down. The main concern with black holes is always going to be gravity. Their gravitational pull is so intense that anything that enters it compresses down astronomically until it becomes a singularity. In simpler terms, black holes are like cosmic vacuum cleaners that suck everything in. One of the scariest parts about the research that's gone into black holes is the fact that if someone were to fall into one, they would get stretched to the point that they become a single line. This process would happen slowly, and the person would die before the final form actually sets in. So, let's just say that no one should be stepping into one. But they're all over, so could we really be in danger? Despite the fact that the closest black hole to Earth is 1,500 light-years away, it's still close enough to bring up questions and concerns. In 2021, scientists were able to release the first clear photograph of a black hole, specifically the M87 black hole. This black hole was photographed several nights in a row, and with each photograph the researchers gathered more and more evidence about it. They had to stitch the individual photos together to create something that filled all the gaps. This way they were able to figure out that there are 3 layers to a black hole. It's not just one single gaping hole of nothingness as many people believe. Things are a lot more complicated than that. To even get to the nothingness part of a black hole, you have to make it through the first 2 layers. The first layer is called the event horizon. It's the point of no return. Once you pass the event horizon, there's no turning back, and you will be sucked into the black hole. The second layer is the photon sphere, which is the region where light orbits the black hole. Any light that enters this region will be trapped and will not be able to escape the black hole's gravitational pull. Finally, we come to the third layer, which is the singularity. This is where everything that enters the black hole gets compressed down astronomically until it becomes a singularity. The singularity is a point in spacetime where the laws of physics as we know them break down, and we just can't predict what happens next. At the singularity, the density is infinite, and the laws of physics as we know them cease to exist. Now, what makes all of this infinitely worse is the fact that every single black hole you study will be entirely different from the last. Sure, they do tend to follow the same three-layer concept, but the way they function could be vastly different. Now, if this were anything else, all we'd need to do is hop back on those telescopes and just study the problem at hand in detail. But with black holes, you can't really do that. Scientists can only study black holes indirectly by observing the radiation they emit and the gas and dust that surrounds them. Sending a probe like the Voyager inside a black hole is not possible because anything that enters the event horizon is pulled toward the singularity, where it is compressed to an infinitely small point. So, you can't exactly waste billions of dollars just to get a glimpse every time, because the second the probe gets close enough, it'll just crush into nothingness. Because of that glaring problem, scientists are left with no option but to study these objects in a two-dimensional way, even though they are three-dimensional phenomena in reality. To make matters even more challenging, there are also the two problems of every black hole being unique and the laws of physics as we know them breaking down when we try to explore the inside. This means that the traditional methods of scientific inquiry don't really apply to the study of black holes. That doesn't mean that the researchers haven't been busy. There are lots of different theories and explanations of black holes, and with each one, things get more and more interesting. Theories. One of the most compelling theories about the formation of black holes is that they are created from collapsed stars. When a star exhausts all of its fuel, it can no longer produce enough energy to counteract the force of gravity that is constantly pulling inward. As a result, the star begins to collapse in on itself, becoming smaller and denser as it does so. If the star is massive enough, this process can continue until it becomes a singularity. To understand the nature of black holes in depth, NASA scientists turned their attention to the core of the galaxy M87. Astronomers observed a super-powerful whirlpool of superhot hydrogen gas that was spinning at an astonishing rate of 1.2 million miles per hour. The sheer force of this spinning disk of gas should have caused it to violently fly apart in all directions, but it didn't. Scientists deduced that there had to be a colossal mass concentrated at the center of the galaxy to prevent this from happening. This massive object weighed as much as 2 to 3 billion suns and could only be a black hole. But that's not the only theory where black holes spin. In 1963, the New Zealand mathematician Roy Kerr used Einstein's equations of gravity to provide the best description of a spinning black hole. Kerr showed that a spinning black hole wouldn't collapse into a point as previously thought, but to a ring of fire or a thin disk. The disk would be spinning so rapidly that centrifugal forces would keep it from collapsing. This spinning disk of matter is called the ergosphere, and it is the region surrounding the black hole where the laws of physics start to break down. But the most intriguing feature of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also known as a wormhole. This is a theoretical passage through space-time that connects two separate regions of the universe, or even two parallel universes. The idea is that if one were to fall into a black hole instead of being crushed to oblivion, one would be sucked down a tunnel through the ring of fire and shot out a white hole in a parallel universe. To understand how this works, we need to look at the concept of space-time in Einstein's theory. Space and time are not separate entities but are interconnected, forming a four-dimensional fabric called space-time. Objects with mass warp this fabric, creating a gravitational field that causes other objects to move toward them. Now imagine a sheet of paper representing space-time. If you place 2 points on the paper and draw a line between them, this is a representation of how objects move through space-time. But what if you could fold the paper in half and create a shortcut between the 2 points? This is the concept of a wormhole, a tunnel that connects two separate points in space-time, allowing for faster-than-light travel. While this is purely theoretical, it's a fascinating idea that has captured the imaginations of scientists and science fiction writers alike. But the fun doesn't stop there. The discovery. Michio Kaku recently announced that a photograph has finally been taken of a black hole, which could reveal what lies inside it. Scientists have been trying to capture an image of a black hole for decades, and this is the first time they've been successful. This photograph is not just a blurry, vague image. It's clear and detailed, showing the structure of the black hole and what lies within it. This discovery is groundbreaking because it confirms the existence of black holes and provides us with a way to study them in more detail. Kaku's announcement has sent shockwaves through the scientific community, as this is a major breakthrough in our understanding of black holes. The photograph was taken by the Event Horizon Telescope, a network of radio telescopes around the world that work together to create a virtual telescope the size of Earth. The image shows a bright ring of light surrounding a dark region, which is the shadow of the black hole. The bright ring is caused by the light bending around the black hole's massive gravitational field, and the dark region in the center is the event horizon, beyond which nothing can escape. This is the first direct evidence of the existence of an event horizon, and it confirms the predictions of Einstein's theory of general relativity. But the discovery doesn't stop there. The photograph also reveals something unexpected, a bright spot in the center of the black hole's shadow. This bright spot is believed to be the light from a photon ring, which is a region of space where light is trapped in a stable orbit around the black hole. This is a major discovery because it confirms the existence of photon rings and provides us with a way to study the behavior of light in the extreme environment of a black hole. The photograph also provides new insights into the nature of black holes and how they interact with their surroundings. For example, it shows that black holes are not just empty voids but are surrounded by a complex structure of gas and dust that is being pulled into the black hole's gravitational field. This structure is known as an accretion disk, and it plays a crucial role in the growth of black holes. As matter falls into the black hole, it heats up and emits radiation which can be detected by telescopes. This radiation is what makes black holes visible to us, even though they themselves are invisible. The photograph also shows that black holes are not just isolated objects but are connected to the larger structure of the universe. For example, the black hole in the photograph is located at the center of a galaxy, and it is believed to be connected to other black holes through a network of cosmic filaments. This discovery opens up a whole new world of possibilities for the study of black holes and the universe as a whole. For example, it could help us understand the nature of dark matter and dark energy, which make up most of the universe but are still largely mysterious. It could also provide new insights into the nature of space and time and the fundamental laws of physics. But perhaps the most exciting possibility is that it could lead to the discovery of new forms of life in the universe. Some scientists believe that black holes could be the key to understanding the origin of life and that they may even contain the building blocks of life itself. For example, it has been suggested that the extreme conditions inside black holes could create the right environment for the formation of complex molecules, which could eventually lead to the development of life. Conclusion. In conclusion, Michio Kaku's announcement of the discovery of a photograph of a black hole is a major breakthrough in our understanding of the universe. It confirms the existence of black holes and provides us with a way to study them in more detail. This discovery has far-reaching implications for the study of black holes and the universe as a whole, and it opens up a whole new world of possibilities for the future of science. As we continue to explore the mysteries of the universe, black holes will undoubtedly play a crucial role in our quest for knowledge and understanding. So, while they may be terrifying, they are also incredibly fascinating, and we can't wait to see what new discoveries lie ahead.